Imagine for a moment you're trying to get one perfect, crystal clear 4K video source onto, I don't know, a dozen or more screens. Flawlessly, right? Without a single hitch. We're talking like a bustling sports bar showing the big game, maybe a critical command center with multiple data feeds, or even, that dream home theater setup with displays everywhere. For years, the go-to has been traditional HDMI cabling, sure. But what if we told you there's a fundamentally different, far more powerful way? One that leverages the networks you probably already understand. Okay, let's unpack this. Today, we're diving headfirst into a fascinating piece of technology that's truly changing how high definition video gets distributed. It's the WolfPack 4K 60 SDVoE HDMI splitters over a LAN. We've gone through some incredibly detailed source material from HDTV Supply, and our mission, as always, is to kind of cut through the jargon, understand the tech, and get right to the core of why these systems are, well, not just remarkable, but maybe essential for modern AV.
Yeah, what's really fascinating here is how these systems leverage existing network infrastructure, stuff that's often already there, to solve what have historically been, let's be honest, incredibly complex and expensive video distribution challenges. We'll explore not just what they do, but why this approach is becoming so crucial, for achieving that uncompromised, seamless, high-quality display in almost any demanding environment. And it raises a big question, I think, for anyone involved in Pro AV. How do you get truly uncompromised video quality across multiple, maybe widely spread out displays, especially when the old ways they can't keep up or become a logistical nightmare?
That's the crux of it, isn't it? So let's start at the beginning. When we say HDMI splitters, you might picture like a simple little box with a few outputs, but trust me, these are definitely not your grandma's splitters.
No, what?
These WolfPack systems, they're specifically designed for distributing video up to, get this, 18 4K 60 Hz TVs. That kind of scale, that quality, it's a huge deal for specific professional settings. Like you said, think about those sports bars where every screen has to be perfect, or mission-critical command centers. Split-second, artifact-free visuals are just non-negotiable there.
Absolutely. Decision-making depends on it.
You need that one source to look absolutely pristine on many, many screens all at once, no hiccups.
Precisely. And traditional HDMI splitting.
Yeah.
It runs into serious limitations pretty fast, real operational headaches.
Yeah.
You start seeing signal degradation over distance, issues with reliable handshaking between devices.
Oh, yeah, the dreaded HDCP issues.
Right. And scalability challenges.
Yeah.
I mean, trying to run dozens of long, stiff HDMI cables across a large building, it's not just a physical pain. It's prone to interference, signal loss, and it gets incredibly expensive to install and maintain. This WolfPack system, it tackles that head-on by moving HDMI distribution onto a local area network, a LAN, using this tech called SDVoE. Connecting this to the bigger picture, it's really about leveraging existing, robust network infrastructure for, frankly, superior AV performance, which crucially can really change the whole cost model for big AV installs. You can grow iteratively.
Right, not just one massive, potentially obsolete investment up front. Okay, that is a powerful shift. So this SDVoE, when I hear video over Ethernet, my first thought is usually, compression, latency issues, things that can mess with quality. Or our source calls SDVoE a network AV encoder-decoder system. How does it actually beat those common problems? What's the secret sauce here?
Yeah, that's a critical distinction. SDVoE stands for Software-Defined Video over Ethernet. It's a standard, a technology, specifically designed to deliver uncompressed, zero-latency audio and video over standard Ethernet networks.
Uncompressed, okay.
That uncompressed part
all
is
right.
absolutely key. It means the picture you see on screen is truly, pixel for pixel, identical to the original source. Unlike so many other AV over IP solutions that, well, they have to compress the signal to send it, which can lead to those visible artifacts, maybe loss of fine detail, distracting color banding.
Stuff you really notice on high-res screens.
Exactly. SDVoE preserves the full fidelity. For anyone serious about pro-grade video quality, this isn't just about a nice picture. It's about ensuring decisions in critical environments aren't hampered by a lost pixel or a tiny delay that could have, real consequences.
Yeah, costly misinterpretations or operational issues.
You're seeing the source exactly as it was created, period.
That's a powerful claim, identical to the original source. Okay, as I was looking through the source material, a few tech specs really jumped out at me. Things like 4K 60 HDMI over LAN WHDR, 4.4.4 color subsampling, and a massive 18 Gbps bandwidth. For someone like me still learning the deeper AV stuff, what do those numbers really mean for the viewer, especially when you get it uncompromised over a network?
Excellent question, because these details, they're the backbone of that premium experience. First, 4K 60 with HDR, so ultra-high definition resolution, 4 times full HD, right? Delivered at a super smooth 60 frames per second. Plus, the HDR, high dynamic range, adds that incredible contrast, much wider color, more depth, makes it look more real.
Okay, most people know 4K HDR now from their TVs.
True, but getting that quality uncompromised across a network
Sure.
over these distances we're talking about, that's the engineering marvel. It's the peak of current video quality. Critical for, medical displays, high-end signage, anywhere detail matters. Then 4.4.4 color subsampling. This is crucial and often overlooked. It means every single pixel carries its full individual color information. No shortcuts. Unlike systems using 4.2.0 or 4.2.2 to save bandwidth, for AV pros, that often means like blurry text edges, brand colors looking a bit off on a sign.
Ah, okay. Subtle stuff, but important.
Very. But 4.4.4 ensures richer, more accurate colors, makes the output indistinguishable from the original source, as the material says. Think raw photo versus a compressed JPEG. You see everything. And 18 Gbps, that's just the sheer data rate needed to push all that uncompressed 4K 60 video and audio. It's huge. Shows you the kind of pipe this needs.
Right.
And finally, HDCP 2.2, also critical. That's the latest copyright protection. Ensures compatibility with Blu-rays, streaming boxes, must have today.
That's a really comprehensive breakdown. The visual fidelity is clearly there. But let's dig into something that, I don't know, still feels almost too good to be true for network video. No latency and no compression. Given the challenges you mentioned with other methods, what makes this system able to deliver that? Are there specific network requirements people need to know about?
Yeah, you've hit on a key differentiator there. The no latency part means there's practically zero perceptible delay between source and display. Our source highlights 100 microseconds seamless switching. That's incredibly fast. Faster than you can blink.
Wow.
Which is absolutely essential for live broadcasts, gaming, interactive stuff, any real-time data where even a tiny delay is bad news.
Right, could be misleading or just plain annoying.
And like we said, no compression for HD and 4K 30 signals ensures that artifact-free transmission of true 4K 60, 4.4.4 happens. Maintains the image integrity. No visual compromises like other AV over IP. It's designed from the ground up to deliver the pure signal.
Okay, but the network needs to handle it.
Ah, yes. To achieve this, you definitely need a network capable of handling that massive 18 Gbps bandwidth per stream, which typically means using high-speed 10 gigabit Ethernet switches. Those 10 Hz SDVoE switchers are crucial for this level of performance.
Got it. So the quality's there, it's fast, but delivering this across potentially a huge area. How complex is it to actually set up and manage all these screens? I mean, since we're using a standard LAN, I guess the old HDMI distance limits are kind of thing of the past. How far can these signals go? What kind of cable?
Yeah, that's the real logistical win with a network system. Huge flexibility in cabling and distance. You can send signals up to 300 feet over standard CT6 copper cables right from the switch. The detailed description even says 330 feet sometimes.
Yeah.
That's pretty solid for copper. But here's the kicker for big installs. You can go way further, up to 1,000 feet, using ON3 fiber optic cables for that same Ethernet switch.
1,000 feet, okay.
Yeah, that gives you significant reach across a campus, a huge home, whatever. Less need for boosters, repeaters. Much simpler to install.
Okay, so you've got signals zipping across hundreds, maybe 1,000 feet of cable, hitting multiple screens. How do you actually control it all? Is it a mess of remotes, or is there a central brain?
No, not a mess at all. That's a key benefit. Control is designed to be comprehensive, but user-friendly. You've got traditional IR infrared. You've got a very intuitive web GI, a graphical interface you access through a browser.
Nice.
And RS-232 for integrating with those bigger third-party control systems like Crestron or AMX. The whole system works with just one control PC. It can even be woken up remotely using Wake on LAN, which is handy.
Oh yeah, Wake on LAN, standard network stuff.
Exactly. And it integrates perfectly with those powerful 10 GBE SDVoE switches we mentioned. So you get a robust central management platform and, this is pretty significant, the inclusion of video wall processing.
Ah, okay, so you can make one giant picture.
Precisely. Stitch multiple displays together into one huge synchronized image for, say, a retail display, or show different content across them in patterns for a command center dashboard. Really creative possibilities.
That sounds incredibly versatile, especially the video wall bit. The source also lists various configurations, like 1x2 splitters up to 1x12, with prices scaling up. That implies huge scalability, right? You're not locked in. Ties back to your point about the cost model changing.
Absolutely. The range of units, with options splitting to up to 18 4K TVs, that clearly shows its modularity, its scalability. This flexibility means you tailor the system exactly to what you need now and then easily expand later just by adding more encoders or decoders to your network.
Just plug more into the switch, essentially.
Pretty much, from a few screens to a massive video wall. The fact that you can build your own SDVoE system starting around $650 suggests that component approach. Buy what you need, grow as you go. That iterative model. Huge strategic advantage. Avoids massive upfront costs, lets systems evolve.
Okay, this kind of sophisticated tech doesn't just appear overnight or from any random startup. Who's actually behind the WolfPack brand? What does their background tell us about reliability, support?
That's a really important point when you're investing in critical AV gear. This system comes from HDTV Supply, Inc. Our source notes they're a 24-year global home for audio and video products, certified since 2003.
24 years, wow.
Yeah, that provides valuable context, confidence. It signals a company with deep experience, established credibility in AV. Being an HDBeta.org approved adopter, while SDVoE is different, still suggests a commitment to industry standards generally. And being rated an exceptional top-quality store rated by Google Shopping. That points to focus on customer satisfaction, product reliability, crucial for complex systems. Plus, the fact that WolfPack and WolfPack are their registered trademarks. It reinforces their investment and ownership, signals long-term commitment to the product line, support. It all points to a reputable provider.
So, wrapping this up, what does all this mean for you? Whether you're planning a new install, upgrading, or just curious about the cutting edge, we've taken a deep dive into these WolfPack SDVoE 4K 60 HDMI splitters over a LAN. We've seen how they really change the game, delivering uncompressed, zero latency 4K 60 video across a standard network. Incredible fidelity, flexibility, turning your network into a high-performance AV backbone. It's way more than just a splitter. It's a whole ecosystem, scalable, future-proof.
Indeed, this tech truly pushes the boundaries, making what was once complex, costly, prone to compromise now seamless, robust, incredibly high-performing. It's a prime example of how networking principles aren't just supporting AV, they're actively revolutionizing it, bringing uncompromised quality, amazing scalability, and real operational efficiency right to the forefront. So, thinking about this immense power and flexibility, uncompressed, artifact-free, zero-latency 4K video zipping across maybe 1,000 feet of fiber. What new possibilities do you think this opens up for large-scale, high-fidelity video experiences, not just in the obvious places like stadiums or control rooms, but maybe enabling entirely new kinds of immersive entertainment for interactive art, maybe in unexpected personal or public spaces? What could you achieve with this kind of uncompromised visual freedom? Something to think